Have you ever encountered a problem so deceptively simple that it splits mathematicians and philosophers into heated debates? Today, we're diving into one of the most controversial thought experiments of the past 2 decades, the Sleeping Beauty problem. By the end of this video, you'll have the chance to decide for yourself whether the answer is 1/2 or 1/3. Let's get started. Imagine Sleeping Beauty volunteers for an experiment. Here's how it works. On Sunday night, she is put to sleep. A fair coin is flipped while she's asleep. 1. If the coin lands heads, she'll be awakened on Monday, asked a question, and put back to sleep. 1. She won't be woken again. 2. If the coin lands tails, she'll be awakened on Monday, asked the same question, put back to sleep, and then woken again on Tuesday. Each time she wakes up, she has no memory of previous awakenings. When she's awake, she's asked one question. What is the probability that the coin landed heads? Take a moment to think about it. What would you say? This problem has led to 2 main camps, the halfer position. 1. They argue the probability is 1/2 because the coin is fair. 1. Nothing changes about the fairness of the coin just because Sleeping Beauty wakes up. 2. Think of it this way. If the coin were flipped before she went to sleep and she was asked immediately, she'd say 1/2. 2. Why should anything change just because she was asleep and woken later? The third position. 1. They argue the probability is 1/3 because when Sleeping Beauty wakes up, there are 3 possible states she could be in. Monday, if the coin landed heads. Monday, if the coin landed tails. Tuesday, if the coin landed tails. 2. Only one of these 3 states corresponds to the coin landing heads, so the probability of heads is 1/3. Let's explore both sides in more detail. The halfer argument. Halfers argue that the fairness of the coin guarantees a 50% chance of heads or tails. When Sleeping Beauty wakes up, she's not given any new information about the coin's outcome. The coin flip and her awakenings are independent events. From her perspective, the chance of heads remains 50%. Imagine the coin was flipped before the experiment started, and she was immediately asked about the probability. She'd say 50%. According to halfers, waking up doesn't change anything because no new evidence is presented to her. The thirder argument. Thirders believe that Sleeping Beauty learns something new when she wakes up, that she is now in a reality where there are 3 possible outcomes. 1. Monday heads. 2. Monday tails. 3. Tuesday tails. Because only one of these outcomes involves heads, the probability of heads becomes 1/3. Thirders emphasize that her subjective probability must account for the fact that she's more likely to wake up in a tails scenario, since tails leads to 2 awakenings. This isn't just a quirky math puzzle. The Sleeping Beauty problem forces us to think deeply about how we assign probabilities when we're part of the scenario being measured. It's related to big questions like, 1. How do we reason about events in a universe with infinite possibilities? 2. What does it mean to have knowledge when we're part of the system being analyzed? Let's take this idea even further. The Million-Wakeups variation. 1. Imagine the same experiment, but instead of being woken twice if the coin lands tails, she's woken 1,000,000 times. 1. If you were woken up in this scenario, would you really think there's a 50% chance the coin landed heads? 1. Or would you lean towards tails because of the overwhelming number of wake-ups? The simulation argument. 1. Some philosophers use a similar line of reasoning to argue we might be living in a simulation. 1. If future civilizations can create millions of realistic simulations of the universe, then it's more likely we're living in one of those simulations than in the base reality. Here are 2 more scenarios to challenge your intuition. The soccer game. 1. Suppose Brazil plays Canada in a soccer match. 1. Brazil is heavily favored with an 80% chance of winning. 1. Before the game, you're put to sleep. 1. If Brazil wins, you're woken once. 1. If Canada wins, you're woken 30 times. 1. When you wake up, who do you think won? 2. Thirders would argue it's Canada because there are far more wake-ups in that scenario. 2. But does that match your intuition? The multiverse. 1. Imagine before the universe was created, a coin was flipped. 1. If it landed heads, only one universe would exist. 1. If it landed tails, a near-infinite multiverse would be created. 1. Now that you're conscious, do you think you're more likely in the multiverse or the single universe? So what's your answer? If you were Sleeping Beauty and you woke up, what probability would you assign to the coin landing heads? Are you a halfer or a thirder? Let us know your thoughts in the comments. And if you enjoyed diving into this fascinating problem, don't forget to like, subscribe, and hit the notification bell for more mind-bending content. Thanks for watching, and we'll see you in the next video.